My name's Simon Johns. I'm Head of IT for Zaha Hadid Architects, and together with my colleague Shaun Farrell, we're going to be presenting on our take on BIM. So thank you for coming along. It's nice to see so many people here. I'm going to be outlining a quick introduction, what it means for us, and some of the social, cultural and technical backgrounds before Shaun plows into the meat of it. So I'm going to be running through who we are, what we do, and what makes us different from all the other architects. So, just to wake you up in the morning, that's Zaha herself, looking splendid. We are based in London. We are 350 architects, all fully qualified. Maybe not all ARB registered in the UK, but all fully qualified in their own country. There's 20 admin staff supporting those 350 architects. And as you can see, we have offices in Hamburg, Rome, Beijing, and a couple of people in Guangzhou, in the south of China, Seoul, and so forth. The majority of our architects, 250 or so, are based in Clerkenwell, which gives us a design solidity there. Zaha's a quite unique character. She was awarded the Pritzker Prize in 2003. She was the first woman to be awarded that. Since then, she's successfully widened the audience for her theories on design, architecture and urbanism. This led last year to being recognised by Time magazine as being one of the top 100 thinkers. The chap in the top left isn't Alan Sugar, it's the President of Brazil. I have to read the name because it is quite long. Luiz Inácio Lula da Silva. The guy on the bottom right is the famous cigar smoker Bill Clinton, and she shares the stage with Lady Gaga, which from my perspective kind of lightens the award somewhat. Each of the dots here represents where we have current projects or good built projects. You can see there's a good spattering across North America, through Asia, North Africa, Middle East, and currently into China. We like to do things a little differently. Our geometry, well, we like curves, we like straight lines as well, and we like to make things a little bit different. So we're primarily known for buildings with strong identities. We like to enhance and amplify the significance of the location, such as these exhibition spaces, cultural performing arts centres, and museums. Last year we won the Sterling Prize for our museum in Italy, the Maxi. We also do sports facilities, such as this small local swimming pool out in the East End, near the newly opened Westfield Stratford City Shopping Centre. If there's any engineers in the audience, there's some steel work of it being built. We do transportation, we do master planning. We also do a couple of tall buildings here and there. We also do product design. So we've got everything from kitchens to furniture, dining room tables, some bags, and well, our first motor car. Zaha's allowed us to expand the repertoire from the early beginnings of radical design theories from our first build projects to a wide portfolio. Whilst maintaining the rigour of design consistency, we've developed sophisticated delivery pipelines, which Shaun's going to allude to later. And we feel this makes us almost unique in contemporary architecture. So, the Zaha way. Our tool palette. We're not an AutoCAD house. We're not a MicroStation house either. We design in Maya and Rhino and Alias. We take the drawings through to MicroStation or AutoCAD architecture. We use Geary Technologies digital projects. We use Revit. I'm sure there's a few that I've forgotten. Our tool palette is as broad as it needs to be. It gives our architects complete freedom in their design. It gives very interesting pipelines, where we try and melt Maya models with Revit and take it through to digital projects. We're a very diverse practice. Out of our 350 staff, we have 44 nationalities represented. We speak in total about 60 or 70 languages. We have a very collegiate atmosphere. Most of our architects have come through the Architectural Association. Most of them can code in Visual Basic or C#. We have a number of architects who actually go to Autodesk and teach them how to do Maya, how to parametricize it. As I said, our portfolio is very broad, from tall buildings to icons, from shoes to electric cars. They have a great amount of freedom in their design process. Unfortunately, a lot of this leads to complications when we try and choose BIM. The rigors of BIM don't sit well with 44 different languages, and we're trying to train different cultural backgrounds, different pipelines, different people with different issues, and melting in different products. So, we're all still awake, and that's not Zaha, I'm stressed about in the middle. Some IT background of how we support BIM before we move on. We have 80 terabytes of live data. We snapshot hourly, we replicate it. We have 40 terabytes of archived data. We have a 10 gigabit network backbone over which we replicate our data. Our IT is fully outsourced, which makes us extremely flexible and very cost effective. Our DR policies are tried and tested, and we like to go for cutting edge software. Everything's now is Windows 7. We run Link, Exchange 2010. We run Office 2010. We run the latest versions of everything. We beta test for most of the software that Shaun will talk about. And there's the BIM. What's BIM for Zaha Hadid? Well, it's not Revit. We use Digital Project. We use MicroStation. There's other products out there as well. So, without further ado, I'll hand over to Shaun.
Excellent. Has anybody heard that phrase before? PBT, people, process and tools. Or is it a new one to many people? Everyone has people in their practice. Everyone has tools in their practice. The application of both is the bit in the middle. That's what will either make it successful or fail abysmally or have you turn your hair out and jumping off the bridge. I'm going to talk about specifically two projects where I hate the use of the word BIM. I think BIM came out of the back of an in-flight manual that some bright spark wrote. There you are, that'd be a good idea. Let's go back and do that in the office. You'll see rafts of adverts for BIM managers required, or government delegating that BIM shall be used, or the American government saying you shall provide a BIM project. I've actually asked the client, what do you mean by that? Oh, we don't know, we were just told we've got to have it. That is the God's honest truth. They do not know. They've just been told they have to have it. So our goal with looking at BIM or VDC, virtual design and construction, which is I think a much better term, gives a much better flavour for what it is, because predominantly architects tend to leave the I out. In the audience, architects, hands up. Engineers, contractors, QSs, project managers. There you go. So that's three sectors that are recognised that are crucial to getting the job done. It's all well and good if, as a process, we come up with a process to say that, well, I'm going to work in 3D over here, and I'm going to give you a 3D model, and then QS turns and goes, we just need polylines, because that's what we do, we measure polylines. You'll never convince them to get a 3D model if they have a process optimized to absolutely nail quantities, and all they need is polylines. They don't need a 3D model. So our goal is to build a project within the given constraints, whatever they may be, maintain the highest levels of quality for design and execution, whatever they may be. But what it is important is the ongoing involvement of members throughout construction documentation. So that's everybody, not just engaging with the engineer, the mechanicals, the MEP, but QSs, estimators, client organisations, FM. What do they need from whatever activity it is you're doing? So I'm going to talk about one project in particular. It's currently on site. It's a building for Aramco, which is the largest petrochemical company on the planet. Wikipedia them yourself, it's quite good fun reading. So we were commissioned to do a research centre in Riyadh. These are some of the interiors of, just some visuals of the project as it's going to be when it's finished. Some quite fun interiors. And I'll show you one slide at the end how we've started combating these particular challenges. Courtyards, interior of Masala. So this project's made up of essentially 5 buildings connected together by a canopy. So we've got a research centre, which is essentially offices, not laboratories, but offices. Conference centre, a library, an IT centre, a religious building in Masala, and a canopy that's connected all of them with a basement underneath. So these are some of the auditoriums. That's the canopy that connects all the buildings together. That's currently as it stands on site. I do believe Aramco do have their own satellite, so it's quite easy to get photos like that. Or they just borrow one. Merrily going away, it's not an insignificant size of project. You'll probably notice there's an awful lot of straight and vertical columns in that photo. There's not a single one on the project. I don't think there's even a single vertical surface on the project. There are no curves for a change. As Simon said, we like curves, we like lines. When we do lines, they tend to be sloping ones. Not an insignificant steel structure. Each of the buildings on this site are built in different methods. So because of the different size, the different nature, and the different purpose, they've all got different structural solutions. That's painted white because it's cantilevered and exposed to the outside air. And because the cladding system's going to be white, that's a 30-metre cantilever in that steelwork. So that big bit on the end isn't going to have a column underneath it when you take away that structure. So the client, largest petrochem company in the world, never carried out a building project of this type before. If you were to look at their standards that they give out, they gave something in the region of 3,000 in-house standards that we had to comply with, from operations to use to delivery to title blocks. So it's a whole range from micromanagement of data right the way up to the running of the facility that we had to read and ingest all of them. You can tell their approach to building, the fact that those of us who have to look at CAD, they have 2 layers for architectural CAD data, which are walls and doors. Because essentially, they wrap sheds and doors around petrochemical facilities. The deliverables for the client, as specified, were 2D, DGNs, and PDFs. Now, we actually got a little bit of a waiver on that because none of the team used MicroStation. So we just looked at their standards and it says you can deliver AutoCAD. So we said, we'll deliver AutoCAD. And they went, but you want DGNs? Yeah, but it says we can deliver an AutoCAD. Okay, thank you very much. So it does help to read client standards. So sometimes you'll get told one thing, and then you read through their own documentation, and you can find it and do something else. So it always pays to read through those waves and waves of information. We, however, wanted to work in 3D. Now, in our practice, the way design usually starts is people will do hand sketches for about the first half an hour a day, and then they reach literally for their sketchbook, which is Rhino or Maya. They go straight into that. There's no 2D drawings. It's sketchbook straight into 3D. We don't like doing 2D, to tell the truth. We much prefer to work in 3D because it's a much more natural thing. But we'll come on to some of that in a second. So we did accept the client requirements. Yes, we'll deliver flat 2D CAD and PDFs. But we did then say, well, it would be good for a building of this complexity to have 3D modeling for team coordination. So the team agreed, no matter what the client wanted, we said the only way we can achieve this is if we work in 3D. We did eventually, as time went on, persuade the client that hybrid deliverables are required for some packages. You saw the complexity. There is literally no way to describe that accurately in 2 dimensions. Some people, there's a saying that says about 2D deliverables and drawings. You put on a drawing the things you've thought about and leave out the things you haven't. And then you deliver a drawing. So you can't, you said, I considered all these things, I'm going to give you a drawing because now I'm legally obliged to work to that drawing. If you can't see it on there, you don't have to worry about it. You can't do that with 3D. You can if you chop the model up, But you do get the butterfly effect when you're working in 3D, whereas if you start linking everything together parametrically, and then you alter something, it's going to ripple through. And that did happen on a number of occasions in our project, where we were looking at the courtyards, which I showed you a photo of. We wanted to line the mullions up with the floor plates. But the moment somebody moved the mullion up, it affected the roof and 3 other roofs further down the building, just by moving 1 mullion. So when you're looking at your 3D models, you'll be very aware of that butterfly effect, as I call it, of design change rippling through the entire structure. The client did have other ideas, but accepted it when the design team all agreed. So the weight of the design team changed the client's mind. Not about the final deliverable, we were still going to deliver flat drawings and PDFs, but how the team could work and deliver some hybrid deliverables, which is to say that we'll give you some drawings, but it will help you if we give you a 3D model to understand exactly what's going on, and there'll be less mistakes because people will realize what's going on. This is where it sort of backfired. What actually, I'll add that one in as well. I'll go to the last one before the one below it. Because the 2D were still the deliverables, a process came about where we're saying legally, because the lawyers love it. Any lawyers in the room? No? Good, okay. Legally, the binding contractual document was the 2D drawing and the PDF. So what the client wanted to say is, because that's what I'm going to be using to build the building before the 3D decision came along, I want you to deliver 2D, and then I'm going to pay a third party to build a 3D model from it. And if there's anything missing, we're going to spank you. So let that one absorb. You've got a 2D deliverable, you can hand it all over, and then they're going to try and, before they build the real building, so it doesn't get expensive, they're going to build, oh, go back one. Before they, put that down so I don't gesture it again. Before they build the real one, they're going to build a virtual one, but from the deliverables you've given them. That is actually happening quite a bit in the world today, where contractors, which is why I asked about contractors in the room, are building 3D models prior to construction to make sure it is buildable and correct. Because the design team haven't collaborated, or they've tried, or only the architects have done the 3D model, and mechanical might not have, or structural might not have, or they've done a model over here and they couldn't get it together in time. So I can fully well see there'll be a new phase before the contractor starts building, or when a contractor does a bidding process, he will build a 3D model from the designs he's been given by the design team, and then says there's something missing here, they haven't considered this bit over here, or they haven't considered that bit over there. And then the client will go, well, I paid you for this service, why is it missing? So take that one on board. Which is where item number 4 came in, 4 or 5, I thought I should put numbers on. But the client wanted a 3D model then as his checks and balances for what he has paid for. I have paid you for a service to deliver a fully designed building. There's gaps. Where are those gaps? So that's when we started saying, well, we're going to deliver 2D information for the bits that come in are easy to do in 2D, like room schedules. Can't get out of those, you still need room schedules. But for complicated things like those curving roofs, or any area where there could be contention due to the fact that 2D drawings only show plan, elevation, section, you can't look around them, we'll deliver some 3D information. Obviously, with our design, with all the sloping surfaces, trying to set out on a sloping surface, almost a nightmare, a lot easier to do in 3D. So that was that project. So that was, again, my presentation is very much more about how the client perceives BIM, as well as then how we then need to interact with the client on that regard, rather than just what the collaboration has been done between the design teams. Because you did see that with we have a number of applications for our own internal use. We have collaboration challenges internally before we start collaborating externally, trying to send the information out. We have one project where, as Simon rightly said, we don't say to people, thou shalt design using this piece of software. No, thou shalt design with any piece of software you like to use, and then we'll figure out how to make it work afterwards. Because it looks awesome in that software they've done, and it wins competitions, and then we have to figure out how to build it. So that's when we come into the workflow, the pipelines of Rhino, Maya, AutoCAD, digital project on one project by one design team, before we even start talking to the other applications used by engineers. Soho Beijing. I quite like the design of this scheme, I have to admit. Combination, multi-use, go back one. Retail, parking, offices. not the easiest of shapes to build. This one's most definitely curvy as opposed to the CapSart project being all nice and straight lines. We do like to interfere with the landscape as well, as you can see on that one. Not just the building on a flat piece of landscape, we like to do the landscape as well. So in this one, in Simon's slides where he shows, we do the whole range of things, all the different types of projects, master planning, landscaping as well. Nice curvy bridges between curvy buildings in an earthquake zone. China does like its earthquakes. That's not a computer rendering. That is the sort of management suite that's currently on site. So you know when you go to a housing development, they say this is what the finish is or the quality of the building is going to be like. Well, that's the management suite currently on site. So there was a light bulb moment, and I'll show you it in a second, is when the client took on the concept that working in 3D would be a damn good idea to do it. And the fact that the current project which we're looking at now is Galaxy Soho, which is at the top. And you'll see down here that this is a significantly larger building, but done in a shorter time frame. This is a smaller building, done in an even shorter time frame. That's at long last people learning from history. And everyone knows that quote. So we've proved that the process that we applied in the first project, Galaxy Soho, can be replicated, and the client actually wanted to replicate it, which is the use of a coordinated model to make sure that you don't mess up on site. The methods we used for generating our 3D models, as I said, were not specific to one data house or one form of data. But we do actually have a method behind it, right? This is where the process comes in. The fact that we have driver geometry, that is to say, a controlling shape which controls the overall form. Outside of that, you have an envelope. Inside of that, you have structure, plus then the structural systems. So we have one form driving all others and linking them together. Now, they don't actually even have to be in the same application or even from the same company. But the idea being that you have a shared common, almost setting out form, which then gives you your zones of influence to say that you shall not work within this, you shall always work outside it, thou shalt not go outside this, thou shalt always work within it. Very simple forms. That's before it starts getting complicated with structure, obviously, because then that structure threads through everything. So that is our architectural model to date. Those are all the bits done by us. One thing that I like scaring architects with is they always say, the question is, who owns the model? Simple answer, the client does, they paid for it. You can debate them till the cows come home, but the client will say, I paid you for the services, I want the drawings, I want the PDFs, and I would also like the model now. They have every right to ask for that, unless you put it in the contract, you're not going to get it. But then you might start a fight, you probably lose. So another thing to bear in mind though is that if you did VDC, BIM, whichever, to its nth degree, the architect, this is going to upset the architects in the room, probably some of the structures as well, by the time you finish, there'll be nothing in that model that you modelled. Because each discipline, each manufacturer, each subconsultant will have put in their bit, which then replaces the bit you put in. So when it comes to design, copyright, and IP, if you actually haven't done any data, what are you protecting? It's not as if it's photography and you've got the negatives. So that's one thing to think about. If you take this to its ultimate end, there is nothing modelled by the architect left in there, because the cladding consultants put in the cladding, engineers put in the engineer, the manufacturer's taken out the engineer's model and put in the real ones. So in the end, ownership becomes very spread. So in some ways, it's actually easier to say, yes, it is the client's. This was the light bulb moment. You saw these had curvy domes on top. At this point in time, you said there was M&E in here? M&E? Sorry, I'm upsetting that. They'd only given us 2D line work, elevations and sections. They weren't on board with 3D at the moment. So all we did was take their plans, extrude them, and stuck them inside a model, and that's what happened. The client immediately signed off on everybody working in 3D. Simple as that. One demonstration to the client. Saying that will happen if we hadn't checked it in 3D. Which then resulted in that. So what actually happened on this project was there was a third party doing all the coordination of everybody. So that the third party was, for want of a better word, independent. And that the client could trust them. Because that also happened in the CapsArt project, is that the client wanted the model builder or model controller to be on their side. They had doubts about whether somebody who was on the design team side being completely honest with the client about coordination issues, which is where the challenge of delivering your 2D and I will get somebody to make a 3D model to check your work. Quite where that mistrust has come from, I have no idea. But it seems to be a general mistrust of the industry by clients, unfortunately. And we need to repair that, and fast. That was after we did the exercise, and that's an ongoing exercise. The project's currently on site. The client also started using it themselves for doing just very simple clashes. It just goes to show that there are no holes in those beams, as there should be. And that ducts do crash into each other. I don't know what it says, it's in Chinese. That's the final structural M&E landscape and architectural coordinated model that's currently being used to build the project. We did do, as you're all well aware of, actually using the 3D model in team meetings. So you actually talk about problems in the 3D model. This one did scare me when I first did it. A manufacturer's one-to-one model of the entire facade, including nuts and bolts. They're going to build from this. They're going to manufacture from this. It's not saying, oh, there's a detail somewhere. They went in and modeled it to make sure they could actually make every single fixing. Mainly because of the, it's curvy, bendy and all that. If you just had a straight facade, you could probably get away with it. But we did do on-site mock-ups. One-to-one, go in, have a look around, see what it feels like. The reason I've shown you that one is because we still do that. You'll never get away from that. Guy going on site with a piece of paper going scribbly, scribbly, scribbly. As I said right at the beginning, there are processes that are efficient, they've been proven, they work, and they're streamlined. Don't try and change them, but you can improve them. That is to say that capturing that information and making sure it's then communicated back to the 3D modelers efficiently, rapidly, and accurately. Workflows. This was first pass. That is to say that we'd have the main model in the middle with a loop of design, go into the model, build it on site, laser check it on site, feed it back to the model, alter the model if necessary to suit on-site conditions. Because you could do the most wonderful 3D model in the world, someone goes on site and puts it in the wrong place, you're still going to have a problem. So that loop is often left out. That is to say, check what's been built on site, alter the model to suit. And we still have this one going on. We've still got 3D design coordination, because as much as we'd all like to say, oh, there's been a design freeze. Anybody had a design freeze that never stayed frozen? Because of things that change on site, or things that happen in the supply chain, or someone goes bust and you have to change everything. One of our projects we designed, I haven't got the slides here, value engineered. In the time it took to do that, the contractor went bust. They had to get a new contractor who wanted it re-value engineered and reassessed. So that was another, it wasn't this project, but another one. The project, the route we actually ended up with was more like that. And the fact we actually haven't got to the laser scanning part yet, people are going to site the old school way, measuring and feeding that information back. With a third party doing the BIM coordination. So there's a design coordination exercise, then it goes out to a third party who then does everyone's coordination, including the reports back from site. So it's allowing the designers to carry on in one loop, whilst then their designers then carry on to a third party, then has another model which has the feedback loop from site. That's it on site at the, well, it's probably about 6 months old now, but that's the viewing centre that I showed before with the nice pretty columns in it. Going away, great guns. Again, lots of nice purely vertical columns. And going on site with laptops. Checking things on site with laptops. Any questions?